Today, we're going to talk about functions, and you probably learned a fair amount about functions when you were in high school, but functions are so foundational to what we do all semester long in pre-calculus and on into calculus and other math classes that we really want to take some time to get a good foundation before we go on. So I want you to think of a function like a machine. So we'll say, all right, here's our function machine. An excellent artist. And a function takes some kind of input and then gives you some other kind of output. All right, so a typical math kind of function would be an equation. Most of our functions will look, with y's and x's. So like the equation y equals x squared. So you might give an input of a number. So you might say x is equal to 5, and then it uses the equation to figure out the output. 5 squared is 25, so the output is that y is 25. Okay, but you could have all other kinds of functions. Like another kind of function might be a chart that you see in a parking garage. And the input you give it is the number of hours that you've been parked there. And the output that the chart gives you is the amount that you owe the attendant as you leave the garage. Okay, so you might get the idea that a function is just a rule that associates two variables or two quantities, and that is true, but we're a little bit more picky about what we call a mathematical function. So let me give you another rule that associates two quantities that does not qualify as a mathematical function. All right, so what if we use as our rule the dictionary? And the input you give it is a letter in the alphabet. And the dictionary will let you know all of the words that start with that letter. So like I said, this is not a mathematical function. And the reason why is because of the number of outputs that you get. So for a rule to qualify as a mathematical function, each input can be assigned only one output. Okay, so for a function, each input, which for us is usually going to be x, each input or x value is assigned one and only one output. And again, for us, our output will usually be y. If it helps you to remember, input and output go in the same alphabetical order as x and y. So for example, our y equals x squared function, each value of x that you're going to plug in, you square it, you only get one value of y. You're never going to square a number and then get two values. Same thing with the chart at the parking garage. If you've been parked there for 5 hours, it's not going to give you two different values that you're going to owe when you leave the garage. But when you plug a letter into the dictionary, you get hundreds and hundreds of outputs. And while that is useful, it just does not qualify as a mathematical function. So now you know what a function is. I want to talk about function notation. So once you have an equation that you know qualifies as a mathematical function, like our y equals x squared, we change the notation a little bit. We replace y with our function notation. So instead of y equals x squared, we're going to write this notation. Okay, and that looks a whole lot like something that usually means multiplication. Usually if I write like 2 parentheses 3, I mean 2 times 3. Okay, in this case with the f parentheses x, we're not talking about multiplication. We read this as f of x, and it is not multiplication. That can get kind of confusing, so you really have to use context clues whether we're talking about function notation or multiplication of numbers. So why do we do this? Why do we complicate things by replacing a perfectly good variable with 4 different symbols that kind of look like a different operation? It's not just to confuse us, it's actually to help us write things more succinctly. So with the equation y equals x squared, I could write the statement, when x equals 5, y equals 25. Okay, we can say that entire statement instead with function notation. With function notation, we're going to write f of 5 equals 25. Written this way, we're still telling you that y is equal to 25 because function notation is another way to write y, but With function notation, we have this little window that gives us this extra piece of information that says, hey, by the way, that y equals 25 came from plugging in x equals 5. So we don't have to write a whole sentence, we've just kind of put it together in notation. So the rest of this video is just going to be getting used to this function notation and evaluating functions at different values of x. Our first example asks us to evaluate f of -3 for f of x equals 5x squared minus 2x plus 1. So again, all they're asking us to do is to figure out the value of y when x is equal to -3. Okay. So all they're asking us to do is go over to that equation and replace all of the x's with -3's. So they're replacing x with -3. So I'm going to go over to this function, and everywhere I see an x, I'm going to replace it with a -3. All right, so what I like to do is to pull all the x's out and leave them with empty sets of parentheses in their place. So 5, where there was an x, I have parentheses squared minus 2, empty set of parentheses instead of an x, and then plus 1. And then everywhere there used to be an x, I'm going to replace it with a -3. And then the rest is just arithmetic. So I'm going to get 5. 3 squared is positive 9. -3 squared is positive 9. -2 times -3 gives me a positive 6. Then plus 1. Do my multiplication first. I'm going to get 45. And then I've still got these guys, or plus 7. And that's going to give me 52. All right, second example, evaluate f of 5t for f of x equals the square root of 2x minus 1. The problems in this section are going to start to look a little bit funky. They're going to be asking you to plug in all kinds of strange things for x. Right now, we're just practicing the skill of evaluating function notation, so just go with it. So they have asked us to replace every x in this function with 5 times t. So I'm going to go pull all the x's out of my function. So instead of f of x, I pull out the x. Instead of 2 times x minus 1, now I've got a blank minus 1. And we're going to replace all of those blanks throughout the function with a 5 times t. And then whatever simplification you can do, go ahead and do it. Let's see, 2 times 5t would give me 10t, and that's going to be about all I can do with this one. And since we don't know what t is, we can't really figure anything else about this one. We're just going to call that our final answer. Next example, let's evaluate f of -x for f of x equals 2x minus 3 divided by 5x plus 1. All right, so some of the stuff they're going to ask you to substitute in for x are actually variations on x, but you follow exactly the same procedure. They have replaced x with -x. So you're going to go over to the formula. Everywhere there was an x, you're going to leave that window. Okay, so I've recopied f of x. All of the x's are missing, and we're going to go replace them with -x's. And then whatever arithmetic we can do to simplify. And I get, let's see, 2 times -x is -2x, minus 3 hanging out there at the end, -5x plus 1. There's a whole lot of negative going on there, but because of the addition and subtraction on top and bottom, there's actually nothing that we can cancel out or simplify in this fraction. So this one, you just have to leave alone. Let's try one more. All right, this last one asks us to evaluate g of x minus 3 for g of x equals the absolute value of 5 minus 2x. This function has a name g. We don't always have to use f for a function. We frequently use other letters for the name of a function, and that's fine. So this one's called g. And absolute value, let's take a minute to remember absolute value. So absolute value tells you the distance a number is from 0 on the number line. Okay, so if we're talking about the number 3, that's 3 tick marks away from 0. So the absolute value of 3 is just 3, that distance. The absolute value of -3, that's also 3 tick marks away from 0. So we would say that the absolute value of -3 is equal to 3. So when we're talking about numbers, absolute value tends to just lop off the negative signs and leave positive numbers alone, which is fine for numbers. If you've got an x inside the absolute value, like we do, 5 minus 2x, we actually don't know what number 5 minus 2x is. It could take on lots of different values, either positive or negative, depending upon what x is. So you can't really make that negative in the middle into a plus because we don't know what number this is. So just leave it the way it is. Let's go ahead and do the function notation. They're asking us to replace the x's with x minus 3's. Okay, so I'm going to copy down my formula, g of x. I'm going to take out all the x's and leave the little window in its place. And then inside the parentheses, I'm going to put my x minus 3. So I can simplify within those absolute value bars using all the arithmetic rules I have. So I can distribute this 2 through the parentheses, leaving the absolute value bars there. So I get minus 2x plus 6. And I can combine the 5 and the 6 to give me 11. So I'm going to say 11 minus 2x. And again, because we don't know what the value of x is, we don't know if this is a positive or negative number, so we can't really simplify with that absolute value. So just leave it there, and that'll be our answer. So we'll learn more about functions when we meet together in class.